We're going to look at right angle triangles. Right angle triangles are very unique because every time they change their angles, all the ratios between the sides change. And that's what we're going to spend a bit of time looking at. The right angle triangle has one right angle and has two other angles. And the three angles all added up will always equal 180 degrees. 1, 2, 3. All added together make it 180 degrees. When we look at a triangle, we've got three sets of sides that we can compare. We can compare this side and this side. We can compare this side and this side. And we can compare this side and this side. So to compare these sides and get some ratios, we first have to label the sides. When we look at a triangle, we can look at it from two directions. We can eyeball it from this way, looking at it this way, or we can look at it from this angle up here. So the first thing you've got to do is just got to pick one angle and run with it, okay? Because it can be looked at two ways. So let's pick this bottom angle here. Once we've selected our angle, we can then label the sides. The side opposite the angle we call the opposite, or O for short. The longest side on the triangle we call the hypotenuse. HYP for short, or just straight H. OH, and the last side is the adjacent side, A for short. Notice if we were to look at it from this way and look at this angle, the hypotenuse still remains a hypotenuse, but this now becomes the opposite and this becomes the adjacent. Now that it's labelled, there's three things on the triangle we can compare. We compare our opposite side to our hypotenuse side and come up with a ratio. We can compare our adjacent side against our hypotenuse and come up with a ratio, and we can compare our opposite against our adjacent, and once again come up with a ratio. And these will be unique for every angle of the triangle, because as the triangle changes shape, these ratios will change. Right, we're going to look at the labels for these three ratios. The first ratio we call the sine ratio, and that equals the opposite over the hypotenuse. So when we're doing sine, we're comparing the opposite and the hypotenuse and come out with a ratio. The next ratio is the cosine ratio, and that equals the adjacent over the hypotenuse. So we're going to compare the adjacent with the hypotenuse in that ratio, and the last ratio is called tangent, and that ratio is the opposite over the adjacent. So we're going to compare the opposite divided by the adjacent, opposite over the adjacent. To help us remember those ratios, we use this word here, so, ka, toa. So it's just a word to help us remember that the sine equals the opposite over the hypotenuse, which is the first ratio. The cosine is the adjacent over the hypotenuse, and the tan is the opposite over the adjacent. From that word we can generate three triangles. The sine equals the opposite over the hypotenuse. The cosine equals the adjacent over the hypotenuse, and the tan equals the opposite over the adjacent. With these three ratios, we actually wind up with nine different formulas we can use to resolve a triangle. That gives us a lot of flexibility. If we knew what the opposite was, for example, we could from these triangles we could get their little hand, we could cover up opposite, and we could tell us that that would be the sine of the angle times the hypotenuse. And it's also, if we covered opposite over here, it would tell us that it would be the tan of the angle times the adjacent. So if we know one side and an angle, we can work out all the other factors in a triangle, because these three ratios give us a lot of flexibility. Let's look at how where we find these ratios on our calculator. If we had a triangle like this and we knew one of the angles, say that was 37 degrees, we would label the sides and we could look at all the ratios of that. The sine ratio is the ratio between the opposite and the hypotenuse. And to do that on our calculator, we push sine, which is right there, and then the angle equals, and that will return the ratio to us. And the sine of 37 gives us a ratio of 0.6018. That's telling us a ratio between the opposite side and the hypotenuse side. If we ever get the ratio, because sometimes we do know the sides of a triangle, we can work out the angle. So let's have a quick look at that. If we knew that this triangle had a side of 12 there and 10 there, we could look for a ratio that would suit that. So what we do is we label the sides. This becomes the opposite, the hypotenuse, and the adjacent. And we're looking for the ratio between the adjacent and the hypotenuse, which is this one here. So the cosine of the angle equals adjacent over hypotenuse. Cosine of the angle equals adjacent over the hypotenuse. Adjacent over the hypotenuse would be 10 over 12, which is the same as saying 5 over 6. And 5 over 6 equals 0.8333. In this case here we know the ratio, but we don't know the angle. But on our calculator, we can do that as well. So let's have a look at that. Let's rub out that one. Okay, so all we've got to do is we just load in the ratio first, which will be so on our calculator, not only do we have sine, cosine, and tan, but just above them in yellow writing is the inverse, which is the sine inverse, the cos inverse, and the tan inverse. And to get to those, we use the shift button first. So we push shift, and then sine, and that will give us the inverse of the sine. So if we had the ratio and we wanted to know the angle, we'd go shift sine. If we had the angle and we wanted to know the ratio, we'd just use sine. So let's go back to this triangle here where we've worked out the ratio of the ratio between the adjacent and the hypotenuse is 10 over 12, which is 5/6, which is 0.833. Adjacent over hypotenuse is our cosine. So what we can do is we know the ratio, we need to find the angle. So this is where we use our shift cosine, which will give us the angle if we tell it the ratio. And then we load in 0.8333 equals, and that will return the angle to us. And the angle for that equals 33.5 degrees. Just to check on that now, we can clear that out and we can put 33.5 degrees into our calculator and find out the cosine of it to find the ratio. So if we put cos 33.5 equals, it will return the ratio to us. So we can work this both ways. We can put the angle in and get the ratio using the cos, sine, or tan, or we can put the ratio in and get the angle using the inverse cos, inverse sine, inverse tan.